Alright, welcome back. In this video we're going to discuss cloud computing and specifically server virtualization. And server virtualization is the process of dividing a physical server into multiple unique and isolated virtual servers by means of a software application. And each virtual server can run its own operating system independently. Right, so this is a way to turn one physical system into multiple systems and servers, basically, and so you get these high-powered, multi-CPU, multi-gig RAM servers, and then you can run a virtual server on this physical server using virtualization software. And each server can run its operating system. And so let's go into what this looks like, right? So this is an illustration of a hypervisor, which is the virtualization software that runs on the physical server that allows you to run virtual machines or virtual servers. And so it's just computing software, firmware or hardware that creates and runs virtual machines. And then a computer on which a hypervisor runs one or more virtual machines, it is called the host machine. So the physical box is called the host machine, and then each virtual machine is called a guest machine. Right? And so in this picture here we've got 4 virtual machines or 4 guest machines, all running on one physical server. The hypervisor presents the guest operating system with a virtual operating system and manages the execution of the guest operating systems. Right, so it actually does the talking, between the storage and the CPU. For each of the virtual machines, but the virtual machines themselves don't realize that they're on, that they're a virtual machine, and they don't have direct access to the CPU and storage. So multiple instances of a variety of operating systems may share the virtualized hardware resources. For example, Linux, Windows, and even Mac OS instances can all run on a single physical machine. This contrasts with operating system level virtualization, where all instances, usually called containers, must share a single kernel, though the guest operating systems can differ in the user space, such as different Linux distributions, but they have the same kernel. And so we'll probably cover that a little bit later with containers and containerization a little bit later. For the most part, we'll deal with this standard hypervisor model right here that's depicted, and go from there. So then we also have different cloud platform models, right? So a cloud deployment model is the type of architecture that a cloud system is implemented on. And these models differ in terms of management, ownership, access control, and security protocols. These models can also be distinguished based on their business model, functionality, and billing systems. Alright, so on the left you have the on-premise. Alright, so this is you have your own data center, you control everything, you're responsible for everything from the server hardware all the way up to application code. But that's if you have it on-site, on-premise in your own data center. Then we have the first type of cloud platform is the infrastructure as a service, and IaaS, and you can see that the responsibility is broken up in half, right? So the cloud provider is responsible for the server hardware, the storage hardware, the networking and virtualization. whereas the user and customer would be responsible for the OS, database security, and application code. And then we have the platform as a service, the next one in the middle, PaaS, and the cloud provider is responsible for almost everything, server hardware up to security, and then the user is just responsible for the application code, and then finally the full-blown cloud provider software as a service. The cloud provider provides everything, including the application code, and the user just consumes the application. Yeah. And so a somewhat example of that would be Teams. In a way, it's a software as a service, right? Gmail, things like that. It's technically a software as a service. You're providing the software or the service, and they're responsible for managing everything, and the user's just using the service. So infrastructure as a service, right? It provides businesses with ready-to-use IT infrastructure. Remember, it was just basically the server hardware network that the cloud provider provided, but it's good for development environments, private networks, secure data storage, instruments for software development and testing, functional monitoring. The enterprise doesn't need to build and secure their own IT infrastructure. They fully power the development process with third-party servers and cloud backup storage. So it's a very simplistic model. The EC2 part of AWS, which we will get into, is a infrastructure as a service where you're renting the servers, and AWS provides the hardware, and you're responsible for everything OS and up. But they provide the network and the physical hardware for the servers. Let's see here. And then platform as a service, right? So it's software that provides access to development tools, APIs, deployment instruments. Users receive access to virtual development environments and cloud storage where they can build, test, and run their applications. And so AWS also offers that. I'm trying to think here. The Beanstalk, I think, is a platform as a service, because they handle a lot more of the deployment tools and things like that, and deploy everything, and you just pick kind of what you need, and it deploys it and does everything for you. So it's a little bit more managed by AWS than the EC2, which is the infrastructure as a service. And then, of course, the software as a service, essentially a web platform that provides users access to cloud computing on a subscription basis. Instead of purchasing the solution one time as it would be a product, the software is delivered continuously like a service, right? And so on AWS, some of that could be the messaging service. So they have a messaging service, email service that you can use, and allows you to send emails and that, and you just pay for what you use, and it's there, it's always available. But they provide all the infrastructure and everything to provide that. we'll throw this in here even though it's not really a platform model. But there's this concept of serverless workloads or serverless computing. It's a cloud computing execution model in which the cloud provider runs the server and dynamically manages the allocations of the machine resources. The pricing is based on the total actual number of resources consumed by the application rather than on a pre-purchased units or capacity. So what this means is you just pay for what you use. In AWS, this is serverless is called Lambda, and Lambda allows you to write just a little snippet of code called a function, and does a specific task or a set of tasks, right? And it can be pretty complex, but you just pay for however many seconds and how much RAM that it actually takes to execute your code when it gets called, right? And so you can have these little snippets of code, and you can create your whole application based on possibly some static web pages and then some of these lambdas, and you can create an entire application in which you don't really have a server running. I mean, the code will run on a server, but it's presented to at you as if it's just a little function of code snippets, and you don't worry about managing the servers. Amazon manages the servers, and you may one instance of the call runs on one server, and then the next time it gets called by a user clicking on something, it runs on a totally different server. It's not tied to any one server in the infrastructure, and so it's really in essence a serverless workload, and you pay just for when your code runs, and so it's a much cheaper solution, especially for startups, things like that, where you don't have to be paying a monthly fee to run a server 24/7. You just pay for when the code executes and runs, and it's pretty cheap, and you get like millions of executions free, at least I believe it's like 1 million executions minutes or month or whatever, something like that, seconds a month, and we'll get into that, but it is pretty intriguing what they're doing with serverless. Excuse me. And then of course cloud is scalable and elastic, so we have scalability and elasticity, and scalability is used to fulfill the static need, while elasticity is used to fill the dynamic need of an organization. Scalability is a similar kind of service provided by the cloud where the customers have to pay per use, and system scalability is the system's infrastructure to scale for handling growing workloads requirements while retaining a consistent performance. And then cloud elasticity is a system's ability to manage available resources according to the current workload requirements dynamically. So it's also the ability to scale down, right? Because when you don't need the resources, you need to tear them down and get rid of them so you stop getting charged for them, especially in the cloud where you only pay for what you use in most cases. In most cases it's not a predetermined monthly fee. It's you pay for each second that it's used. And so if you no longer have that need, you need the systems to be able to scale down as well as scale up. All right. And then scalability, we have vertical scaling or horizontal scaling. So vertical scaling can handle and increase workloads by adding resources to the existing infrastructure in the short term to cover immediate needs. And then that's scaling up. So you add more RAM, add more CPU, right? You make it bigger, you scale it up. Horizontal scaling is scaled out, where it expands the existing infrastructure, and you add new servers or resources to tackle more of the workload. In the long term, it is a longer-term solution aimed to cover present and future resource demands with room for expansion. And then there's a diagonal scale. It's a more flexible solution that combines adding and removing resources according to the current workload requirements. It is the most cost-effective, scalable solution by far. And scalability is essentially an essential factor for a business whose demand for resources is increasing slowly and predictably. Then elasticity is defined as the degree to which a system is able to adapt to workload changes by provisioning and deprovisioning resources in an automatic manner, such that each point in time the available resources match the current demand as close as possible. So this is also a vital feature of our infrastructure. It comes in handy when the system is expected to experience sudden spikes of user activity, and as a result a drastic increase in workload demand. And then thanks for the pay-per-use modeling of cloud platforms, cloud elasticity is a cost-effective solution for businesses with dynamic workloads, like streaming services or e-commerce marketplace, right? Think about seasonal events like Christmas, Black Friday, and other big news spikes or events, right, where workloads explode for maybe short or even a little bit prolonged, maybe a week or two prolonged period of time, but then they drastically shrink after that. So you need to have the systems be elastic enough to handle both extremes. You want it to be able to expand to handle the Black Friday traffic, but yet scale down after the New Year's, right, when there's no more demand after Christmas, right? The retail demand is a tenth of what it is around Black Friday, probably even more. Alright, so much of the attraction of cloud computing is the ability to pay for only the services you use and only when you use them. And this allows the provisioning of sophisticated applications with virtually no capital expense, no CapEx, right? You will, of course, need to assess and manage the operating expense, or OpEx, because it can get out of control. So it's very easy to spin up thousands of servers, and thus your bill in the cloud. So it's very easy to have your budgets run away from you. So OpEx control is paramount in the cloud. Server virtualization makes it possible to do more densely packed software operations on physical servers, potentially driving down the cost and improving the time to deployment of our workloads. And even more virtualized kind of virtualization is serverless computing, where consumers are aware of their code and network events that trigger it. So it's a totally different way. The serverless is a totally different way of creating and managing applications, but it does provide fantastic scaling and cost savings. So by developing cloud optimized workloads, you're design them to take advantage of the scalability and elasticity of the cloud platforms. All right, so this ends our lesson. We'll go into our next lesson, which let me see here. Going to be understanding our AWS account.